So now we're going to be putting all of this stuff together for real world scenarios. Again, there's only like 4 problems on your homework that deal with that. You should do them all the way 1 through 17. But now we're going to do real world scenarios. So we're just looking at this lovely little picture. We have a tree, we have an acorn, and we got a little squirrel. And we're going to see how far the nut is from the base of the tree based off of the given information. So we are looking for how far away is it. We've been given that the tree is 14 feet tall, and this angle here is 74 degrees, which our squirrel is looking at the nut. So we're looking at this angle of 74. We are just setting them up like our proportions that we just did. So what this says is I have been given this angle. I now need to find and determine, am I using so, ka, or toa? Okay. So I am next to my angle, meaning I am adjacent, and I am opposite of the ground, so opposite. So we have O and A. So we're going to be using toa. So that means tangent of 74, because we're using toa, opposite over adjacent of 14. Set it up our proportion. We put this over 1 and we're going to cross multiply. So again, variable first, I get x times 1 is equal to 14 tangent of 74. Plug that into our calculator and we're going to approximately get 48.824. But what is it? We have to look for our units on these. So this one says feet. So we have our nut away from the tree about 48.824 feet away. Okay. Real world scenarios. This is why trigonometry is so important. Okay. So, Mr. Griffin wants to know the height of a tree. So, we want to know the height of a tree. I'm going to say this is tree because I can't draw. He walks exactly 100 feet from the base. So he's walked 100 feet from the base. And he's going to look at the top of the tree. So he's looking at the top of the tree. The angle from the ground, so this is our ground, to the top of the tree. So we're looking from the ground to the top of the tree. This is the top of the tree. Of about 33 degrees. How tall, or unknown, is the tree? Okay, so setting up the triangle is so important. Make sure you do that. All I did was follow along. Height of a tree. The tree can only be straight up and down. Ground is on the ground. Eyesight, you can make it our hypotenuse. So because we've done that, this is a right triangle. All we have to do now is set up our proportion. So we're looking, we have an angle of 33 here, and we have 2 things that have been given to us. So our 100 feet is adjacent to our 33 degrees and is opposite to our tree. So once again, we are looking at TOA, opposite over adjacent. So now that we've done this, we can say tangent of 33 is equal to opposite x over our adjacent 100. We have set up our proportion, and now we can cross multiply. Variable first, x times 1 is x, and it's going to equal 100 times tangent of 33. So x is approximately 64.941, and based off of our past given stuff, it says 100 feet, so that means that this tree is approximately 64.941 feet. Okay. Drawing a picture is important, and all I do to draw a picture is I read and start drawing as I go. That is very important. You have to read the problem. Okay. So C, you are flying a kite. Sweet. We have a kite. And it's 60 feet above the ground. That means here's ground. Here's our ground. From ground to the kite is 60 feet. I've just read the first sentence. And the angle the string makes, so we know our string has to be over here, because our string can't be on the ground, and it can't be straight up and down, so this is our string, has an angle from the ground to the string, so ground to string, of 40 degrees. See how I made that triangle? This is a right triangle. So how much string, so we need to find our string, are you currently using? So that's our x, that's our unknown. Now that we have this, we can see we have a 40-degree angle, and we need to determine what is 60 and x to it. Well, 60 is opposite of 40, and x is our hypotenuse, it's opposite of our right angle. So we have OA. So looking at OA, we're going to be using sine. So we say sine of 40 is equal to opposite of 60 over our hypotenuse of x. We are just solving our proportion. Put it over 1, we cross multiply, variable first, x times sine of 40 is equal to 60 times 1. I want x by itself, so I divide by sine of 40, so we get 60 divided by sine of 40. We plug that into our calculator, and we're going to approximately get that it is 93.343 feet, because we're 60 feet above the air long. So our string is almost like really long, 93.343 feet. That's our string. That's awesome. All right, I would like you to take a moment, maybe pause the video. You have 2 problems I'd like to say that you can do on your own. Make sure you're able and capable. That way you know you're awesome for your homework. I erased the SOHCAHTOA. Oops. If not, please make sure you're checking with me. Okay? So back to SOHCAHTOA. I will still do these 2, that way you can check your answers at the end. Okay. So pause, try and do them on your own. 1, a ladder leaning against a house. Okay, I'm not even gonna look at anything else. There's a ladder and it's leaning against a house. Is a house on the ground or sideways? No. So our house has to be straight up and down, and our ladder is leaning. That means it's not on the ground. So we say this is our ladder, and this will be our ground, okay? That creates a 90 degree, because house to ground is 90 degrees. You don't see any cocky houses all over the place. The house makes an angle, so against the house. The ladder leaning against a house, so we have our ladder leaning, makes an angle of 30 degrees with the ground. So from ground, so this is our ground, to ladder is 30 degrees. The foot of the ladder, so this is the foot, that means the bottom, is 7 feet from the base of the house. So that means from the base of the house to the foot of the ladder is 7 feet long, okay? How long is the ladder? So it wants us to know what the ladder is, because more than likely that house is actually taller than the ladder. So that's pretty reasonable. We have drawn our triangle, and now we're going to create our scenario. So we have a 30 degree, and we need to see what x and 7 feet are to it. Well, 7 means it's adjacent to it, and x is opposite of our 90 degrees, so our hypotenuse. So we have a and h. So we're going to be looking at cosine. So cosine of 30 degrees is equal to adjacent of 7 over hypotenuse of x. Same process, put it over 1, cross multiply, variable first, x times cosine of 30 equals 7 times 1. Get x by itself. We see x is equal to 7 divided by cosine of 30, which is approximately 8.083 feet. Okay? Again, we've been doing a lot of things with feet, so more than likely it's feet. So you have about an 8-foot ladder. It's kind of cool. All right, our last one for notes. Last one for A 60-foot ramp. That doesn't give us enough information for me to start drawing, but a 60-foot ramp rises from the first floor to the second floor of a parking garage. Okay, so that makes a little bit more sense. So we have a ramp. This is our ramp, and it's 60 feet. That rises from the first floor to the second floor. So this is our floors. And this is probably more than likely our ground, which causes a 90-degree angle. I just read the first sentence. Ramp says it rises from first to second. Okay, so that means our ramp is our hypotenuse that moves. We have floors, which is our height, and then ground, which is always the same. So the ramp makes a 15-degree angle with the ground. Okay, so ramp between ground means this is 15 degrees. And we want to know how high above the first floor is the second floor. Okay, so how high are our floors? You have set up a triangle. Looking at the information given to us, our 15-degree angle is here. Over here, ramp, definitely our hypotenuse. It's opposite of our 90 degrees, and it's the one that's diagonal. Looking at x, it is opposite of 15 degrees, so we're looking at OH. OH is sine. So we say sine of 15 is equal to opposite of our x over 60, our hypotenuse. We've set up our proportion. We put it over 1, we cross multiply variable first, and we're going to get x is equal to 60 sine of 15. Plug it into your calculator, and it is approximately 15.529 feet. Okay? Alrighty. That is the end of the intro to trigonometry. We will be continuing. This is our second to last lesson. Woo! Please make sure you are watching these videos. Thank you.